right, here we go. We're gonna see how this works. Got my little makeshift classroom here in my kids' playroom. We have like this little chalkboard on a mirror closet I'm gonna use so you guys can kind of follow along with me, and we're gonna work on a probability experiment together that we would have done together in class. So I thought this was the next best thing. So we're gonna talk about dice today, and so a simple six-sided die, okay? And we're gonna talk about theoretical probability, which we've already talked a little bit about, and then how that's different from experimental probability. So the first thing we need to do, if we're going to try and figure out, what are the chances of rolling any particular number on a dice, first we need to know that there's only 1 through 6 are my total options, and there's only one of each of them. This is not like a trick dice, okay? So if I'm going to write that down, my theoretical, can you guys see that? Yep. Probability. Okay, so my probability theoretically, so I've not actually done the experiment yet. My probability is going to be, that's why it's called theoretical. It's in theory, based on facts, based on math, based on what we know about this die, what's going to happen. Okay, so the probability of rolling a 1, okay, so I've got a total of how many outcomes? Okay, 6, because I've got numbers 1 through 6 on here, and there's only one 1, so that's going to be my numerator. So my probability of rolling a 1 is going to be 1/6. You can also write that as a percent if you want to. What do you think the probability is going to be for the other numbers? Yeah, it's actually all going to be the same thing, because there's always 6 of them, and there's only one of each number. So the probability of each number on this dice, theoretically, is I'm going to roll it 1 out of 6 times. So that is predicting, okay, that's making a prediction based on my facts, based on my numbers, that if I were to roll this die 6 times, I theoretically would get each number once. Now we know that's not what's actually going to happen. Okay, and that's what we're going to talk about more about today. We're going to do an experiment and actually see. Okay, so real quick, I'm going to go ahead and I'm going to roll this die. Let me kind of pull over my little table right here. I don't know if you guys can, you probably can't see it. I'm going to roll this 6 times, and I'm just going to record what happens. So something that's helpful when you are doing an experiment. So now we're shifting into experimental probability. I'm going to actually do this experiment and record the results and see if my experimental probability is anywhere close to my theoretical probability, okay? So I'm going to go ahead and record just a chart on here. 4, 5, 6, just a tally chart of each of these numbers so I can quickly record them, how many times they happen, okay? So I'm going to do this. I've just picked 10, nice round number, okay? So I got a 4, I got a 1, I got a 5, I got another 5, I got a 2, I got a 6, oh geez, 1, 2, 3, 4, 5, 6, 4 more rolls. I got a 4, I got a 6, I got a 3, oh, one more roll, and I got a 3. Okay, so that's kind of interesting. Obviously 6 doesn't work nicely with 10, but I'm going to get either between, based on theoretical probability, I probably was going to get somewhere between 1 to 2 of each number. There's no way to get 2 of every number unless I did 12 rolls. So my experimental is pretty close. For 1, my experimental probability was 1/10. For 2, it was also 1/10. For 3, I rolled that twice, so that would be 2/10, okay, or 1/5, which is really close to 1/6. For 4, 5, and 6, those are all the same thing. They're all 1/5 because I rolled those all twice. Hope you guys can see that okay. So if we do that 10 times, I kind of happen to get pretty close. Now if you guys were to do this 10 times, do you think you'd get the exact same results that I did? Probably not, right? That's the whole point about experiments, is we all get different data. Now, it's extremely unlikely that you would roll a 6 all 10 times, but it is possible. That's why we use those likelihood phrases. That probability is probably very low that you're going to roll a 6 all 10 times, but it could happen. It has happened before. So what we do, just like when Mrs. Ricks talks to you guys, especially about science fair, when you conduct an experiment, the more times you conduct an experiment, in math for probability, we call that a sample space, okay? Our sample space here is 6, or our sample size. We want to conduct this experiment lots and lots and lots of times. The idea being that the more times you conduct the experiment, the closer your experimental probabilities are going to get to your theoretical probabilities. So if I were to just do this 5 times, my probabilities might not be really close to my theoretical ones. But if I were to do this 50 times, it's probably going to get closer. I got kind of lucky here, and I just rolled it. I didn't plan these out. It got pretty close. But if you guys were to pause this and maybe do this at home with the die, I'm curious what you would maybe get. But we're going to go ahead, and we're going to see if anything is different. So let me erase these. And now I'm going to do this, bear with me, 50 times. Now, I'm going to do a little bit of cheating only because I know you guys don't want to watch me roll a die 50 times. So I've got these awesome dice in dice. My kids are obsessed with these right now. It's a dice with a little dice in it. They're regular 6-sided die, but I'm going to put 25 of these in a cup, and I'm going to roll them. And then, sorry for the noise, that'll be 50 rolls real quick, just to save us some time. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 6 more. 1, 2, 3, 4, 5. 1 more. Okay, so, ready? I'm going to pour them out, okay? Okay, so the ones that are facing up are the ones that I'm going to call. So I got a 6 and then a 1 on this one. You guys can kind of record with me. I got a 2 and a 4. This is for 50 times. A 4 and a 1. 2 and a 6. A 5 and a 5. It's kind of funny. A 5 and a 2. A 3 and a 6, a 3 and a 2, a 3 and a 3, again, a 4 and a 3, a 6 and a 4, almost halfway, a 4 and a 1, a 2 and a 1, a 6 and a 4. Can you guys see that okay? Yeah. A 6 and a 2, a 4 and a 2, a 6 and a 4, a 6 and a 6, goodness on the 6s, 1 and a 5, a 3 and a 1, oop, can't see that one really well, there we go, a 6 and a 3, a 4 and a 4, a 2 and a 1, a 6 and a 6, I should play Yahtzee right now, I'm getting all these 6s, 4 and a 2. Okay, so my totals, for 1, I have 7 of them, for 2, I have, what do we have, 9 of them, I've got 7 3s, I have 11 4s, this is interesting, I only have 4 5s, and I had 12 6s. So then when you're reporting your experimental probability, you're going to take the total times that that outcome happened over the total number of trials. So the final thing we're going to do here, so now we're talking experimental, so I'm going to now change these to be my experimental probability. Okay, for 1, that happened 7 out of those 50 times. So my probability is 7/50ths, or you could write that as a percent or decimal if you wanted to. My probability of rolling a 2 is 9/50ths. What is my probability for rolling a 3 for my experiment? Yep, it's going to be a 7 out of 50. How about probability of rolling a 4 for my experiment? 11 out of 50. My probability of rolling a 5 would be a 4 out of 50, and I can simplify that to 2/25. And lastly, probability of 6 is 12/50, or I can simplify that to 6/25. Okay, so what do you think, my final question for you is, what do you think when you're going from theoretical to experimental, what do you think you should be doing when you're conducting trials? Yes, the more trials you conduct, the more, ideally, it won't always happen. In my case, it actually didn't. I had a better results when I just did my 10 rolls as opposed to these. But if I were to do 100, I won't, I promise. But if I were to do 100, it should get closer and closer to that theoretical probability of 1/6 for each of those numbers because they are equally likely. The same thing if you're flipping a coin, it should be 50-50. If you have a deck of cards, like all these different things where things are equally likely to happen, the more you do the experiment, the more closer your experimental will get to your theoretical. All right, guys, thank you so much for joining me, and I'll probably have another one of these next week for us to do together. No, it's not the same thing as the classroom. I miss you guys so much, but we can make this our little e-classroom for now. All right, miss you guys. Bye.